Now let us solve a problem on that. The problem says that an object has a velocity 3 meters per second at origin. The acceleration of a body is given by a equal to minus 3x. Describe the motion and find where the body initially stops. You can see that acceleration is given by a equals to minus 3x, which means acceleration is changing because it is depending on distance. It is depending on where the object is. When the object is at origin, x is 0, acceleration will be 0. It has no acceleration. When the body is to the right, then x is positive and the acceleration will be negative. When the body is to the left, then acceleration x is negative, so acceleration is positive. Let me solve the equation. Let me draw a number line. That is probably origin. Object has 3 meters per second at origin and it has an acceleration of a equal to minus 3x. So initially the object is at origin, it has some velocity, it is moving right. It has some velocity 3 meters per second. So its acceleration is 0 and it has some velocity, so it moves right. Once it moves right, its x coordinate becomes positive, so acceleration will be negative. So velocity will be positive and acceleration negative. What happens? If both have opposite signs, the object slows down, so the object slows down. So it slows down, it will stop somewhere. Once it stops, the velocity becomes 0, but it has acceleration because it has x coordinate, a equal to minus 3x. X is positive, so acceleration is negative, which means body will come back. It will reach origin. Once it reaches origin, it will have velocity towards left. Now, it has some velocity, but the acceleration is 0. So it continues going in that direction. Once it goes to that side, x becomes negative and acceleration, which is minus 3x, becomes positive. Velocity is negative and acceleration is positive, which means the body again slows down. It slows down, stops. Again it comes back, it goes forward, comes back, goes forward. This will be the motion of the object. You understood? Now, he's asking, find where the object initially stops. To do that, I should find a relation between v and x. So that I'll put v equal to 0 and I'll find what are the values of x. What I'll do that is, a is equals to minus 3x, which implies dv by dt is equals to minus 3x, which implies dv by dx into dx by dt is equals to minus 3x, which implies dv by dx into v is equals to minus 3x. It means v dv is equals to minus 3x dx. If I integrate this, integration of v dv from 3 to some final velocity v, I don't know, because its initial velocity is 3. That should be equals to minus 3x dx integration from 0 to x. So that would be minus 3x square by 2. Here I would get v square minus, v square by 2, and I have some limits. 3 to v should be equals to minus 3x square by 2. That means v square minus 9 by 2 is equals to minus 3x square by 2. 2 and 2 gone. So I'll get v square is equals to 9 minus 3x square. So I got velocity as a function of displacement. He's asking where the body stops initially. The body will stop when velocity becomes 0, which means 9 minus 3x square should be 0. So 3x square is 9. So x will be equals to root 3 plus or minus root 3. It seems that if suppose the body starts at origin, it moves to right, it stops somewhere at root 3, comes back to origin, it goes back, it stops at minus root 3. So he asked where the body stops initially. It is root 3. So that's all for the session. We'll continue in the coming sessions. Till then, keep exploring.